Okay, welcome everyone. And in this session, let us discuss about the multi-thread programming. In the previous session, in the previous video, we had discussed about the thread basics in Java. So now we will just extend our discussion where we will bring in this multi-thread concept of Java into programming. Hence, we'll see what are all the properties and how exactly we are going to deal with this. So now, when we're going to talk about a thread, so basically we are going to have a single thread, what we are going to call this as a main thread. So which I'll be discussing in a few minutes. But when I'm going to talk about a thread, so thread is the one where as a programmer I should be able to create it whenever I want, so that I can bring in the concept of multi-programming. So when I am sure that my program is going to have multiple parts which can be executed concurrently or parallelly, so this every part of my program should be treated like a thread. And see, if there are 3 parts in my program which can work concurrently in parallel, we are going to make this each part as individual thread, and each thread will start its execution without dependency or less dependency, and we will see that all these 3 threads will execute concurrently in parallel. Hence, so now when I want to do this, we need to make sure that we will be able to create a thread whenever we want, depending upon what part and what thread I need to create. Hence, my sense here should be, or focus here should be of how we are going to create a thread in a Java program. Hence, for this, whenever you think that I want to create a thread, you have got 2 options available, or you can do it in 2 ways. The first way is you can make use of a class, a thread class, or you can make use of an interface. At this point of time, you should know what is an interface, which contains set of methods, and those methods should be implemented, and those methods is going to be bodiless methods, and those methods should be implemented or defined in the class which it is going to implement. So whereas a class, it has well defined methods, every method is going to have a body. And now if I am extending as a derived class, now if I want to implement the same method, I am going to use the concept of function overriding. Hence, so you can take a call whether you're going to create a thread using a thread class, or using a runnable interface, or using an interface. Hence, we'll discuss both the terms, then we will see which is the better one, or which suits well for my application when I think about a threading concept. Fine. So now to start with this, so when I say thread class, as I told you, I need to use the extend keyword, because I'm talking about inheritance now. And if I'm talking about an interface, I need to implement the runnable interface. The interface name is runnable, the class name is thread. I can do it in 2 ways. And if you're using an interface, you don't have any methods which has been defined. You need to define the body for every method, but the advantage in this case is that you need to implement only one method. I will just tell you what is that method. But when I talk about a class, you're going to have list of existing methods with its body. Now you can just make use of those methods. Now we will see what are all the methods of this class and how we are going to create a thread using class. Then later on we will discuss how we are going to create a thread using the interface as the runnable. Fine. So now just look at the methods what we are going to have. When I say thread class, so we are going to have a set of methods which belongs to this class called as thread, and whatever the methods I have put here, this is not a complete list. First of all, these are the important methods which we have picked and projecting only for this discussion. But if you look at the thread class, it has got still more methods. So we will see it later when we are going to use those methods, but right now we'll focus on only this set of important methods which we can put into our discussion. Clear? And so now this is a set of methods already available in this class. Now I'm going to have a start. Now this is going to be the method which is going to act as a starting point, or we are going to say I have created the thread and let it move on to an runnable state. If you remember, a thread is going to have a life cycle. Starting from new, it will move to runnable. From runnable, it will move to running. I got 3 states. Once I create a thread, it is going to be in the new state. Fine. And when I make it runnable state, that is where this start method will come into picture. And when I execute the run method, so this is going to make sure the thread is in the running state. Fine. Hence, so now I'm going to use this method to start a thread. I'm going to use this method to run a thread. So, but just look at this. When I'm going to a start and run method, you need not call the run method explicitly. The start method will do the job for you. It is going to execute. It is going to call the run method. It will complete the execution. Hence, whenever your thread wants to execute any set of instruction, that will happen from this run method only. Hence, this is the entry point for thread. Similar to a main method as an entry point for any program, the whole application or the whole program. Similarly, the run method is the entry point for your thread. This is how we should look into this. So right now my thread is running. For any reason I want to suspend the thread execution, either for the wait purpose, for the block purpose, for sleep purpose. For any reason, if my thread should go into the waiting state for a period of time, we are going to make use of the sleep method. If I call the sleep method, my thread will go into suspension until a period of time or until a trigger occurs so that it can resume the execution. Fine. And now every thread is going to have a name and every thread is going to have its priority. That is the thread priority what we talk. Something, what is priority value? That is a priority queue or a priority operator. So if I'm going to talk about multiplication addition or a multiplication division addition subtraction, we talk about the priority of the operators. Whichever has the highest priority, first execute that, then execute the lower priority. Similarly, even for the thread, we can have a priority. The highest priority thread will acquire the CPU at high priority than the low priority one. Fine. So we will see how this priority is going to work in our thread concept. But this is what we can get. What is the priority of my thread? And even I can get the name of my thread. As I told you, every thread is going to have a name, and I can check whether the current thread is running or not. That is, whether the thread is still in the execution or it has completed the execution and the thread is to be destroyed or it has been destroyed. To check that status of a thread, we'll use the function isAlive. So this isAlive will determine whether thread is alive or dead. This function will return true if the thread is still in execution. And this method is going to return false if the execution of thread is completed and it is no more existing. That is what we call dead as usual. Right? So now when I'm going to have a method called as join, that is, so now I'm going to have a main method or one method which creates a thread. I'm going to have parent thread, I'm going to have child thread now. Fine. So now, whenever we are going to have these two threads, this child thread will be in execution and parent thread may be in execution. It can get occupied a CPU or it may just sit idle and wait for the thread to complete the execution. Why this parent thread should wait until the child thread is going to complete the execution. This is a strong restriction in your Java program. A parent thread cannot be destroyed, or a parent thread cannot die, or parent thread cannot go out of execution until its child or its children threads has been completed its execution. Fine. That is where if I am going to have 5 child threads of a single thread, and this first thread has completed the execution, it will join the parent thread. And similarly, all the remaining 4 threads also should join. Only then the main thread will say it has completed the execution. Hence, if I use the join method, the parent thread will stay back. Even if it is sitting idle, it will stay back until all its children thread has been completed the execution and it has arrived at the joining point. That is what the join method is going to do. And so these are the few of the methods of your thread class which we are going to use whenever it is required. But the start, run is essential methods we need to use. Remaining methods, it's optional. As the situation demands, we can make use of those methods. This is where we talk about a thread class. And if it is say, if I'm implementing or creating my thread using Runnable Interface, it is just simple. There's no any method in the interface, but there's one method, only one method you should think about implementing. That is the run method. If you are even using Runnable Interface, just keep this point in your mind. You must and should implement the run method as public void run. This is the given function prototype. If you are using a Runnable Interface, it doesn't mean that you cannot use any of this method. You can make use of all these methods available in thread class, because so this interface is also an extension, or this thread class is going to implement this interface. Hence there is a communication, there is a common scenario between these two. Hence if I am using Runnable Interface, indirectly it is like I am making use of thread class. Clear? And this is how we are going to make use of this two. So now we'll just see what is a main thread. So before we start creating a thread, just have a look at main thread. And the reason why we are going to have discussion on main thread is this is a special and important thread. Every program, every Java program should have a main thread, because as we have a main function in every Java program, and every main function will act as a main thread, and this main thread should exist. This is what I told you whenever I'm going to have a child. So this child thread should be created by a parent thread. If there is no parent thread, where do you create the thread? Where do you put the statement for execution to create a thread? It should happen in the main thread. And that is what the thread, this is the thread which starts the execution immediately on program execution. As soon as you start your Java execution or program execution, immediately the main thread will be in execution. Fine. And so this is the thread where we can start creating the threads, where we create a child thread. Hence now main thread becomes the main parent thread. Under this I am creating a thread as child thread. Under this child thread, further you can create any more child threads, or for the main thread itself you can create any more childs. And that is what, so this is the main thread which we are going to use to create the child thread, so which will be spammed using the main thread, or which will be created, or we say the execution line has been split into multiple execution line. And one more major point, as I've earlier mentioned, if I'm going to have parent thread should not complete its execution until all its children will complete the execution. This is what we say the main thread is the first thread to be starting the execution. Under this thread, I'll be creating n number of threads, and hence this main thread is the thread which will exit as the last execution. This is the last thread to finish the execution. This means I'm making sure that the parent thread as a main thread will be the last thread to exit, and this thread will stay back until all its child thread has been completed its execution. This is the importance of having a main thread, and this is the importance of main thread in your Java program when talking about threading concept. Every program will have a main thread. Hereafter, whatever the thread you create, you will be creating under the main thread itself. This will be the main parent thread for you in the program. So now we have a main thread, first point, and this thread is not created by us because this thread is automatically created as soon as the program starts the execution. Hence it happens immediately. Hence the main thread is not created by us. So now when the main thread is not created by us, can I control this main thread? Can I say what this main thread should do, or when this main thread should terminate, or should the main thread stay long enough? What this main thread should do? Can I control this? The answer is yes, you can control. So hence if you want to control, you need to know the reference of the thread. You should obtain the reference of the thread. To obtain reference of a thread, Java provides an function, an inbuilt method called as current thread. So if I use this method for the current thread object, so this is going to give me what is the reference of the current thread. Hence, so main function, we don't know what is the reference because this is created and maintained and executed by the program execution system. Hence, I don't know what is the reference for this main thread. In that case, I can get to know what is the reference, and once I know the reference, I can control the main thread also. Hence this is the func method which we are going to use. So now just look at this example where we talk about main thread. Now I am going to have class demo as usual. I am going to have public static void main. If you observe here, I am not creating any thread here. Remember, this is not the example to create a thread. Hence we are not extending any class here. We are not implementing any interface of the thread here. It is same what I was doing all these days. Class demo, main function, and this main function is going to be the main thread by default for us when the execution starts. Hence I want to take the control of this thread, the main thread, hence I am using the inbuilt method called as current thread. So this is going to return me the thread ID, and so thread is the class name and current thread is a method. So now you can add up this to the list of class thread methods, because when I was discussing I didn't mention about the current thread, so now you can add upon. So now I am going to use the class name and the method name under this class name. Now this will return me the reference of the current thread, which is going to be the main thread right now. Hence I'm going to use T to hold the reference. So when I say current thread, it doesn't mean that it should be always used only with the main thread. This can be used with any thread. Whichever is the current thread, that reference will be returned by this method. Hence after this, I'm just going to print a statement as current thread is. Fine. Now just look at this, what output I'm going to get. So when I print, what is the output you are going to get? Current thread is in a string what I have been formed as a message. So plus T. So the value of T will be printed over here. Now what's the value of T is going to be? So just look at this, what T is going to be. So current thread is the message what I have been typed. And the value of T is this, the information of a thread, the reference of a thread. hence it is a thread, hence I have got the word as thread over here. And between this pair of angular brackets you can see three values. The first value is going to say what is the name of the thread. The name of the thread is main, hence the first value is going to be the main, which is the name of the thread. And the second value or the second parameter is going to be the priority. By default the priority of all the thread is 5, hence right now the main thread priority is 5, and this is going to be the group to which the thread belongs to. Right now by default main thread will always belong to the main group itself, hence I am going to have the thread name, what its priority, to which group the thread belongs to. Hence, so now I am just going to use one more method now called as tSetName, and now you can add up this method to the list what I was mentioned at the earlier as the class thread methods. And I'm going to say my thread now. So now what exactly I'm doing here? I'm setting the name. Fine. That is right now the name of the thread was main. I've changed the name. This is where I'm taking the control of main thread and I'm using it the way I want. Hence I'm just going to print now the message as now the current thread is plus T. Now what output you're expecting? This is an as usual message. Along with this I'm going to print T. Now what does T contains? It is a thread and the name will be changed because I have set to a new name. Hence this is going to be my thread. Priority is unchanged, remains same. Group is unchanged, it remains same. Hence when I print this I'm going to get the message as now current thread is, and the thread instead of main I'm going to have the name what I've been mentioned using this method as my thread, and remaining both are the two values remain same. And once this is done I'll enter the try block and I'm going to print the value 1 and the thread will go into sleep. The thread will go into sleep or the sleep state. And now just look at this. When I use this method sleep, I am passing parameter as 1000. And this sleep, when I pass this as 1000, is going to be 1 second. The thread will go to sleep for 1 second because sleep will take milliseconds as parameter. And so right now the thread will go to sleep for 1 second. Clear? And after 1 second it will resume, it will wake up, it will resume, will come back and print the value of n as 2 and go to sleep, wake up, print it 3, print it 4, print it 5, and once the for loop execution is completed I will come out of my program or the main thread has been destroyed. There's no more main thread. And just look at one more thing, what error the thread can exhibit. The thread can exhibit interrupted exception when it is running and forcefully if an highest priority thread arrives, the CPU should be vacated immediately for the highest priority process or the highest priority thread. In this case the current running thread should be interrupted. That is what we say interrupted exception. If any thread, any higher priority thread arrives and interrupts the working or the execution of a thread, we call this as an interrupted thread, and this is an interrupted exception. And if this exception is caused, I'm just going to print a message as main thread was interrupted. Yeah, so this is how a thread with the main thread is going to work with. Now if I talk about this output and these three parts, as I mentioned, the first one is the thread name, and next is the priority, and next is the group to which the thread belongs to. Yes, you need to understand what values I'm going to print when I'm printing a thread. Clear? So now when I talk about creating a thread, I was talking about creating a thread earlier at the start of this session. and I introduced you what is a main thread, because you should understand what is main thread before you are able to create a thread. And that is the reason why the main thread came in between, to give a clear picture how you can make use of main thread efficiently to create a thread. And so when I'm going to create a thread, and whenever we are going to create a thread, we need to initiate an object of the type thread. We need to create an object of the type thread either as a class or as an interface. Hence, if I'm using class, use extends, or if I'm using interface, use implements. So this is the two ways. So first we will see how we are going to implement a thread using Runnable Interface. Then we'll get back to the thread class. Clear? So now when I use Runnable Interface, I am going to have a class name called as myThread implements Runnable. And when I implement this interface, you need to define the method called as run. Hence, so Runnable abstracts a unit of executable code. Now the part of my program which should be executable, which should be in execution, so that is going to be one unit for me. That is what we say, the Runnable will always abstract, or Runnable will always create me one thread which is going to be one unit of execution for me. Clear? And now class needs to implement a single method called as run. Hence, this is what the run method we need to implement if I am implementing a Runnable interface. And using this can construct a thread or on any object that implements Runnable. Now this class is going to implement Runnable, hence I can construct a object for this class which will act as a thread for me. And that is what we can construct, an object for this class as a thread. Now whatever the object I create for this class, that becomes a thread. Yeah, and every class what you make it as a thread interface or a Runnable interface, you need to make sure you have a run method, so which is going to establish an entry point for me as a main function for a program and an exit point for the new threads. And this is where the thread will be created and thread will be destroyed. And when I'm going to talk about a thread, the thread defines several constructors. So depending upon either we need a zero parameterized constructor or a parameterized constructor, or how many parameters, you can use several types of constructor available in the thread class. So we will see all this. But first look at how we are going to create a thread. And if you observe in my explanation, I am using thread class also. That is, constructor is a thread class. Fine. And establishing or implementing Runnable or creating a Runnable class, all this is going to be part of the thread class. So now when I'm talking about Runnable interface, also I'm referencing the class with the name thread, and there is some sort of communication between these two. And so now using Runnable, so whenever you want to create a thread, the first job is create the thread. And when you're creating a thread, I'm going to use the constructor. As I told you, the thread has got its own set of constructors starting from 0 parameter, a number of parameters. So right now I'm going to use this 2 parameterized constructor. I'm just going to tell what is or to which object the thread should be attached and what is the name of the thread. I should give this 2 information whenever I'm going to create a thread right now. And so once the thread has been created, it will be in the new state. And now to make it Runnable, I need to execute the start method. And the start method will indirectly call the run method. So where the thread will fall into the running state. Hence, if I want to create a thread, make use of constructor and create an object. And if you want to start a thread, use the start method. If you want to execute a thread, I am going to call the run method, and you need not call this. You need to call the constructor. you need to call the start method, and start method in turn will call the run method. Hence, you need not worry about how to call the run method. Is it clear? So now with this, we'll see the example, how exactly this is going to be done. I'm going to have class new thread which implements Runnable Interface, and I'm going to have a data member to hold the reference of a thread which I'm going to create. Hence, I'm going to use the constructor new thread. Inside this constructor, I'm going to use the constructor of the thread class, which is going to take two parameters as I mentioned. One is the runnable thread object, which is going to be the current object whatever I have been using. Whatever the current object is going to be, that is going to be the runnable thread object. And I need to pass the name of the thread. Hence, the second parameter is going to stand as demo thread is going to be the name of the thread. And I'm just going to print out the statement, and I'm going to call the start method. I've created. Now I'm going to start. I'm going to start the thread so that it's going to be in the runnable state. And so this start in turn will call the run method. So hence you need not call this method. This method will be automatically indirectly called whenever I'm going to call the start method. Clear? Hence in this run method, I'm just going to have a for loop from 1 to 5. I'll be printing 1 to 5 values, and as soon as I print the first value, the thread will go to sleep for 500 milliseconds, that is 0.5 seconds. Clear? And we are going to have an exception handling. When the thread is interrupted, I am going to print this message, and at the end I am going to say exit of the child thread. Once this loop is completed, if there is no any exception, the control should come and say exit of the child thread. So this is what I am going to use a class thread. So now I am going to extend this program or complete this program by bringing in a class called as thread demo, which contains the main function. Now in this main function, I am creating an object called as new thread. I am going to create an object for this class new thread. Now this is implementing Runnable, and now this is going to create a thread for me. As soon as I am going to call this, this is going to call the constructor, which is going to be a zero parameterized constructor. And inside this constructor, I am creating a thread. And I'm going to print a message, and I'm going to execute the start. And when I've done this, my thread is ready for the execution. It has not yet started the execution, but it's saying I am ready for the execution. So once this is done, the control will come back to this main function, and it will start executing its instruction. It is going to print the value 1 in the first iteration, and it will go to sleep now. And just look at this. I'm making the main thread to go into sleep for 1 second for every loop. But this thread, I'm making it to go for 0.5 seconds for every loop. So that if this is going to print 5 values, it may require only 2.5 seconds. Fine, that is 0.5 seconds for every iteration. But whereas in this same loop, but the sleep is doubled, hence this is going to take 5 seconds. So this will finish off. This will finish off in 2.5 seconds, and this is going to take 5 seconds. Hence, this will make sure that main thread will stay back until the child thread is going to complete its execution. And I have put some exception handling, and when the control comes here, I'm going to say exit of the main thread. And now just look at the output, what is going to happen. The execution will start from the main function, and I create a thread. As soon as I execute this, the control will come for this zero parameterized constructor. I create a thread with the name demo thread, and I'm going to print this. So I'm going to print this as child thread, plus I'm going to print the reference of a thread, and this is the output what I'm going to get, the child thread and the thread name is whatever right now I given this as demo thread. Priority is fine, and right now by default it belongs to the main group. Clear? And once this is done, the control comes at the start and it's going to make the thread to be in the runnable state, and the control will come back to the main function. And when it come back to main function, it start executing the loop. It's going to print the value 1 and saying main thread 1, and the control will jump to sleep mode, and now my program will go into the sleep mode now, and being in the sleep mode for 1 second. So right now the CPU is idle now. The main thread has been went to a sleep mode. That means the CPU is vacant. When CPU is vacant, so this thread was waiting for execution. This will immediately occupies the CPU, and as this as start method is executed, immediately the run also will be indirectly called. And now I'm going to start the loop. I'm going to print the message as child thread 1, and now this will go into sleep. Now when this goes into sleep, whether this method has waked up, not yet, because it takes 1 second, but in 0.5 second this job is done. And so now this thread will come back and it will wake up and it will execute, because this not yet wake up. Hence the CPU will be acquired by the child thread twice, and after the twice execution this has been waked up. Hence I am going to have main thread. I'll come back and it will go into sleep for 1 second again. I'll come back and I'm going to print the next loop, that is 1 is done and 2 is done. Now I'm going to print 3, and still the main thread is sleeping, hence child thread 4. So now the main thread is waked up, hence the control will come to main method, and main method has printed the value 2. Now it's going to print 3, and the control will go to child and it is going to print fine, and that's it, and the loop is completed, and is going to print the message as exit of child thread, and there is no more thread called as T. Clear? The control will come here. It has printed only 3. It is going to print 4. It is going to print fine, and the execution will be stopped saying exit of the main thread. So this is how a thread program will be executed. Clear? How we are going to create a thread using Runnable Interface, and how this has been executed. So now if I am going to have this, so now we will see how we are going to use the second method and how we are going to extend a thread. And whenever we are going to extend a thread, the run method should be overridden. That means I should redefine the body for the run method. And so now just look at this program. It is similar program. I have not changed or modified anything the previous program what I gave to you. The only change is in the previous example program I add here as implements runnable interface or implements runnable, but now I am extending the thread class. Now this becomes the super class and this becomes the subclass, hence I am using extends, the first change. The second change here is I need not call the constructor directly of this particular class. If I do so, it's not going to create any thread as an object. And now what we should do, I need to make use of the superclass constructor. And if you remember, using superclass, I can make use of, or I can call the superclass constructor by passing a parameter. Hence, instead of saying it as new thread, I'm going to call the superclass constructor. This is the one more change if you are extending a thread using the thread class. Clear? And remaining everything hereafter remains same. Hence I'm going to get the same set of output. And one more very important point, either it's going to be extending a thread or it's going to be the that is going to be the runnable interface. The output what I am showing here is this can vary depending upon system to system. If the CPU is given in round robin, the output can change. Or if the system is going to work on priority, so this output can change. Hence, this is the one possible output what we can roughly figure it out of this program, whatever we got. But the same program, if I execute again in the same system, I may end up with a different set of output because the way the thread works in your system. Clear? This is an example of how we are going to extend the thread. And with this, so in the previous example, I just shown you how we are going to use the constructor of the thread by passing two parameters. So now you are seeing how we are going to use about the constructor using one parameter. Yes, right now you should remember these two types of constructor with respect to the thread class. Fine. So now with this example, now we have got two approaches. Now, which is the best approach we are going to choose with? Now we can create a thread using thread class, and we are going to have a runnable interface which we can implement. Now, which is the best one? This is the big question right now, because we have introduced both the methods. So now we are into confusion. Which should be chosen, or which I should need to choose? Now, usually if I talk about an thread concept, it's better to go with the runnable interface, because you need not override a method. Because if you want to override a method, you need to redefine the body of the method. In the case of thread class, I am forced to do this. I am going to have a run method. I am supposed to redefine the body. I need to restructure the body. In spite of using the same run method what the thread class has got, I need to redefine this method again so that I can achieve overriding. But whereas in runnable interface, you need not redefine, because no body has been defined for the interface or the runnable interface. And so now I'm not thinking about redefining. I'm thinking about creating. I'm freshly creating a run method or the run function of your thread. And so now you've got two scenarios now. One, you need to redefine the body of the run, or you need to create the body of the run. Now just look what your application is demanding, whether you need to redefine or you need to just create. Fine. So now usually if you think about in a blank mind what approach to be used, runnable interface the best approach, because I need not worry about function overriding. Hence, so we are going to use the thread class only when classes should be extended, only when they are being enhanced or modified in some way. If this is the necessity, if you are thinking about enhancing the run method or modifying the run method at the initial stage itself, then think about using the thread class to create a thread. And if you are thinking about just to create a thread and just to define your own run method without bothering about what body earlier the method has got, you can go with the runnable interface, and this is the easiest one. Fine. So for this reason, now whatever the discussion we make hereafter, we are going to make use of runnable interface to create a thread and to manage a thread. Fine. Hence with this, so now we'll see how exactly we are going to have multiple threads, and how exactly we are going to create multiple threads in the program. Now just look at this. I am going to have class new thread implements runnable, and I'm going to have a name in the form of string. I'm creating a data member called as name of the type string, and this is going to help me. This is going to help me to store the name of the thread, and I'm going to have a thread T, and this is going to store the reference of the current thread. And I'm going to have the constructor, where this constructor will accept one parameter, and this parameter, the name what I pass as parameter, will be stored in this data member as the name of the thread, and T will be used to create the thread, and the name whatever I have stored here, that name I am going to pass as the name of the thread, and currently this is going to take the reference of the current thread and store the reference in the thread variable what I have been created, and print the what is the thread, and I am going to start the thread and run execution for a 3 iteration with 1000 milliseconds, that is going to be 1 second, and at the end just print exit of and what thread I am going to exit. I am going to print the name, for example exit of XYZ thread or exit of ABC thread, whatever the name I am going to give. So now in the main function or the main class, I am going to have a main function. In the main function, I am going to create a thread calling new thread 1, new thread 2, new thread 3. Hence, for this constructor, I am passing 1, which will be stored at the name as 1. And next, I am going to pass it as 2, which will be stored it as 2. And 3, the constructor will take it as 3, creates a thread with the name as 3, and it will be stored in this variable. Clear? And I am going to put it as try, and the thread dot sleep I am using 10,000 here, hence it is going to be 10 seconds. And my main method or the main function will go into sleep for 10 seconds. Clear? Hence now I am just going to have 3 threads. I am going to have 3 texts, which each thread will take 1 second of execution, and each loop is going to have 3 iterations and 3 seconds. I got 3 threads, and it takes hardly 9 seconds until it finishes all the 9 seconds of execution. My main thread will be still alive, will be still in execution, because this is 10 seconds. Clear? Hence I am just making sure that the parent thread will be alive until all its thread is going to finish off its execution. Now just look at the output what I am going to get in this case. Fine. So now this is the statement which will be executed first. The control will go to constructor, and the name of the thread as 1 will be stored in this variable, and create the thread with the reference of the current thread, and the name is going to be 1. Name is going to be 1. The thread name is 1, and I'm going to print the statement as new thread plus I'm going to print it as new thread statement. It's a thread. The thread name is 1, priority is 5, and it belongs to the main thread group. Fine. So similarly, and the control will come back. It will going to start the thread, and the run will be executing, but it won't start the execution. The control will come back immediately to the main function, and I'm going to create the second thread with the name as 2, and similarly happens with this printing over with the thread name as 2, similarly with thread name as 3. Now all the 3 thread has been created. Now the execution will start from the run method. Hence when I execute run, I'm going to print the value of 1. I'm going to print the name of the current thread, whichever is in the execution. Right now the thread with the name 1 is execution, hence I'm going to print 1 plus I'm going to print a colon and the value of I, that is the 1. Hence I'm printing 1 colon 1. This is going to be the output. So now it will go into sleep, and the second thread will come into picture. It will start its execution from the loop I equals 1. Hence I am going to have 2, 1. Similarly, now it will go into sleep. Now both the threads are in the sleep, and the third thread will come and it's going to print it. Hence again the same thing will go in round robin now. So 1, 2, 2, 2, 3, 2. Again 1, 3, 2, 3 and 3, 3. So now once all this iteration is done, the first thread iteration is done, and it is going to print the message exit of 1 thread. And even the second thread has finished the execution, exit of 2 thread, and exit of 3 thread. and the control will come back to the main function, and in the main function, after this sleep has been elapsed, it is going to come at this point and print the message as, oh sorry, I think I've just made a mistake here. So this program should also contain the output as exit of the main thread. I missed this output, so please note on this correction. Hence, now this has done this execution. So now the program what I've just shown you with the multi-program, where the main function should wait for 10 seconds until all its child is going to finish. Now the same job or the same thing can be achieved using isAlive and the join. I can make use of isAlive and the join methods of the thread class, which will help me out to make sure the parent class or the parent thread will wait until all its child thread is going to finish off its execution. All these times what we were doing, we are calculating the time. We are calculating the time of every child, what it spends for execution, and approximately we would have computed, we have summed this, and we are given few more extra seconds for the main thread to stay back. Fine. So hence I need to make all this calculation so that we will make sure the parent thread is going to wait until its all child thread has been completed the execution. So now if this is the case, every time which I cannot deal this with, and I've got a solution for this. So I need not every time compute what is the time will be taken by the every child process, so that I can make sure the parent will stay back for that long time. I need not do this, because there is an option called as isAlive method, which will tell me whether the current thread is alive or not, and the join until all its child thread has been not completed the execution and has joined the parent thread will not complete its execution, and so now you need not worry about the time. The main function, if I say join is used, the main function or the parent thread will wait until all its children thread is going to complete the execution. So without time bound. That is what is the effectiveness or the advantage of using isAlive and the join. Hence, so now the same main function have been modified here. The modification here is, now in spite of having new thread 1, 2 and 3, now I need a reference of each thread so that I can check out whether is it alive or dead. And even I can bring this child thread into the join group. Hence for this case I need the reference. Here I need not work on reference, but now I need the reference so that I can work on these two concepts. Hence object 1, object 2, object 3. Clear? So now I am going to print the message stating whether the thread 1 is alive or not, thread 2 is alive, thread 3 is alive, by calling the function isAlive. So I am using the object 1 dot t is the data member of the class my thread, that is the new thread. And so I am using the object, I am using data member where the reference of my thread is stored, and I am going to call the method isAlive, and this method will return me either 1 or it was going to return me it's going to return me true or it's going to return me false. And so right now the thread whatever I am going to use, this is going to be alive. Hence I am going to say new thread 159, and whatever the output I am going to get upon creation, I am going to get this 3 threads. And after this 3 outputs, I am going to say thread 1 is alive, as it is true, it is still alive. Thread 2 is alive, it is true. Thread 3 is alive, it is true. And in the try, I am going to say print the message waiting for threads to finish. That means the main thread, the parent thread will wait until the threads whatever I am going to put in the join method, this parent thread will wait. Hence I am saying object 1 dot t dot join. Hence this parent thread should wait until the first thread will finish the execution, and even the second thread, even the third thread. If I would have not included this object 2 in the join, then your parent would have waited only for the first thread and the thread 3. Hence, whichever the thread the parent should wait for, you need to use all those methods with the join method. And so now it will just go back and print the output as 1, 1, 1, the same output what I had in the previous example. When this is done, the execution of all the 3 thread is done. That is exit of 2 thread, exit of 1 thread, exit of 3 thread. Now all the 3 threads has finished its execution. And so now what happens? Now whatever we are going to have when I call is alive, all the 3 thread has been done the execution. Hence it's false now. It's not alive. Even this is not alive. Even this is not alive. So now don't bother about the order. The order can be anything because this is an parallel execution. And so once this is done, only then, so this statement is executed upon completion of all the 3 children's. If any one would have been not complete the execution, I would have not arrived at this statement. And I am going to print the statement as exit of main thread. This is how we are going to make use of using is alive and join. And now I was talking about the thread priority. So now by default the thread priority is going to be 5. If you want, you can change the thread priority. If you want, you can change this. And how to do this? In your Java program, you have got 2 options. That is, I can set the priority, the 2 functions. I can set the priority and I can get what is the priority of the current thread. So if I just use this method on the object of the thread, I will get 5 for this example. Or any value I can give as an input where I can set the priority of a thread. And the priority value or whatever I'm going to give should be between these 2 constants. That is the minimum priority and the maximum priority. You should give the parameter of the set priority only between this range. Hence, I'm going to say set priority and I'm going to put some value in this, and whatever the value you're going to put here should be between this range, and the minimum priority is 1 and the maximum priority is 10. Hence whatever the parameter you pass as a parameter for this method should be between 1 and 10. And if you want the normal priority to be applied, that is the default priority should be applied, just call this method and pass the parameter as normal priority. If you want the least priority, pass it as min priority. If you want the highest priority, pass it as max priority. If you want the default, that is 5, as the middle priority, just pass the parameter as norm priority. Or if you want any other priority, make sure the value will be between 1 and 10. Is it fine? And this is how we are going to change the priority of the thread if we want and if we think it is necessary. Now this is what you should understand about the threads, how we are going to create a thread, the 2 ways, and what is a main thread, how do I create a child thread using a main thread, and how we are going to bring in the multi-thread concept, how we are going to have 2 or 3 threads executing concurrently, and how we are going to use a isAlive method, and how we are going to make use of the join method. Fine, this is what you should understand about the thread. So in the next session, next class, we'll discuss more about the thread synchronization. And for this session, thank you.